Okay, so we talked about briefly. I mentioned visualizing any property of any pipeline object. So let's just start with something very simple, and we'll create an object from scratch. So in ParaView, you can go to sources, and in sources you can there's an alphabetical list of objects. So let's just bring some object like a cylinder, for example, and click apply. So I went to sources, alphabetical, then cylinder, cylinder, and then I clicked apply. Okay, and then so a cylinder has a number of properties. One of the properties could be so let's see if I enable. Let's see if I see the properties. Oh, I need to click on the cylinder, of course. So one of the properties is resolution, then there is height, radius, center, and so on. So let's change the height of the cylinder. So we'll be continuously changing the height. Let's say from 0. Currently it's 1, so we'll be changing from 0 to 1. Actually, let's do from 1 to 0. So it's going to be becoming smaller and smaller, and then it will disappear. So the way I do this, I will need to go to bring up animation view. I'll go to view, animation view, and then I have a single object, right? So here I have cylinder, great. So I have two drop-down menus. Select cylinder here, and then you need to select a property that we're going to be animating. So we're going to be animating height. So once again, to see this, you go to view, animation, enable animation view, and you will see it here. So I selected for the object, I selected cylinder, and for the property, I selected height. And then I click on plus. When I click on plus, it'll create a new timeline. So usually it's in white. In my case, I use the Unmaki's reverse the dark theme, so it's shown in black. So now I'm going to double click on this timeline, so on the black bar right here. And then it doesn't show much, but it shows this table where time goes from 0 to 1, and then the value goes, I want to change, I will be changing it from 1 to 0 continuously. Okay. So my height, the height is going to be changing from 1 to 0. So I'm going to close this dialog. And then another thing that I want to modify is number of frames. So currently default is 10, which is very small. I want to make it 100 frames, for example. So I actually have a nice animation. And then all I need to do is just play it back. So here's my cylinder, and the height is getting smaller and smaller, right? And as you can see, I can even spin it, I can zoom it, and so on. So it's playing back this animation. And of course, this is not particularly interesting because, well, what I do with the cylinder, but you can do the same for any data set. So let me delete this sorry. Let me delete this timeline. So I click on the the red cross, delete the timeline, and then I'm gonna restart from scratch. So start from scratch, and then I'm gonna download this sine envelope.nc file, the one we looked at before. So for the reader, I need you to use once again netcdf reader. I'm going to say apply, and let's visualize this data set. So I'm going to be looking at the outer surface and color by density. So you've seen this before already, right? Okay, so now what I'm going to do is I'm going to slice it. So I'm going to apply a slice filter. Actually, sorry, a clip filter. So a clip filter. When I bring up the clip filter, it's right here in the toolbar. This filter gives me, I'm not sure if you see it on your screen, but it gives me these controls where I can change the orientation of the plane by dragging the normal. And then once I'm happy with the rotation, I can also drag the plane itself, and it will basically slice it in different ways. So once I'm happy, I'm just going to click apply, and maybe I want to invert it. So like this, okay. And then, so here, what I can do, I can animate the position of the slice, right? So in the animation view, make sure you delete all previous animations. So there should be no black white bars here. So, and then I'm going to go for the clip object in the pipeline browser. I'm going to modify its position. So let's say, I'm looking at the triad right here, right? So what I'm going to be doing, I'm going to be moving it along the x-axis. So the x-axis, in my case, for you it could be different, but in my case, this is the x-axis, right? So I'm going to be moving this animation along the x-axis. So what I'm going to need to animate is for the clip, I need to animate the position. So position are origin 0, 1, and 2. So bad names, but it is what it is. So origin 0 is the x, right? So I'm going to be animating this variable. And then I'm going to click on plus, and then double click on the timeline. So on the timeline, time goes from 0 to 1, the value goes from 0 to 99, right? Okay, well, let's try this. So I'm gonna say a play, and let's see what's happening. So as you can see, it plays back in, let's instead of 10 frames, let's do 30 frames, and let's play back slower in 30 frames. And the speed at which it's playing is actually the processing speed, right? So it takes some time to actually do the it's not the slice, do the clip, and it takes small fraction of a second, but it's still for 30 frames it takes, I don't know, a few seconds, right? So here I get a nice animation. Of course, if you want to have a smooth animation, well, it's very easy. So you just create more frames, and then if I play it back, it will play smoother. And I can so I will uncheck the show plane here. So actually, I see just this guy itself, and then I'm going to go to save animation, and then I'm going to save it in my downloads folder as, I don't know. So I'm going to call it a clip, and then here, unfortunately, I don't have save animation. I don't have a good choice of formats. So the formats AVI don't use AVI. It's a very old format. The only reason they included AVI is because it's free, but it's not good at all in terms of quality. So there's no, unfortunately, MPEG-4 or QuickTime. There are no good modern formats here. So OGG video is a modern format, but almost nobody uses it. And so, unfortunately, the reason why they don't have MPEG-4 here or QuickTime is because of licensing. So including those formats would actually cost them money, and because it's open source free software, they didn't do this. So the best option in terms of quality would actually be to use PNG images. But what this will create actually a bunch of files, and then you'll need to merge these files into a movie. So let's say actually I have I'm wondering if I have a slide on this. Yeah, I have a slide on this. So slide 61 tells you exactly how to do this. But to actually merge them, you have to have a separate tool called FFmpeg. So most likely you don't have it installed, but it's an open source, it's a free software for all platforms. So for Mac, Windows, and Linux, you can install it. So maybe you can just watch what I'm doing on my screen, and then you, if you want, you can recreate it later after the workshop. So here I'm actually, instead of calling them clip, let me call them frames. So I'm saving individual frames as PNG images. So there will be 300 frames. I'm going to say OK. And then here, optionally, I can choose resolution. So maybe I don't need to see super high resolution. I'm just going to do 900 by 900 by 900, and then format. Yeah, everything else is the same. So once I click OK, it will start saving them. So I will actually, inside my downloads folder, if I go there, I should see the files frame. You see those frame, and then for digits.png, and I should create 300 of them. So that will actually take a while, because it's creating those animations and writing them. So maybe it'll create 30 more. It'll take 30 more seconds. And once this is done, I'm going to paste this line. So I'm going to take this line from the slide. Let's do this and this. So what it will do, it will create a file. I'm going to call it clip.mpeg4, and then it will take those original files, frame dot, then for digits.png, and it will convert them using x264 codec, so QuickTime compatible file format. And then, so I have 300 of them, so let me encode them at, let's say, 30 frames per second. So they will create a 10-second movie, right? So let me see, it's almost done, I guess. So you see it's almost done. So I'm saving those. So now I have 300 PNG files, and then I'm going to run this. And then now I created a file clip.mpeg4, which is tiny actually. So this is less than 400 kilobytes. So I can actually fit several of these onto a floppy from 1980, really tiny file, but it's still fairly high quality. So if I play it back, this is what it looks like. So 300 frames, playing 30 frames per second, and the entire movie is 10 seconds long. Okay. So once again, and the entire movie, so this is amazing. It just tells us about the quality of MPEG-4. MPEG-4 and FFmpeg utility compression. So this entire movie is less than 400 kilobytes, which is tiny. All right, so this is by far the best option to create movies in ParaView. So unfortunately, as I said, when you go to File Save Animation, you don't get any modern formats, and that's because of licensing. So what you need to do is select PNG, and then you will need to merge them, stitch them into a movie by using something like this. So there are some other utilities as well. I find FFmpeg is by far the best in terms of ease of use and quality. So produces really fantastic results. There are several other animations. So let's just spend a few more minutes on animation, and then we'll jump to online putting models online. So there are a few other animations you can do. So one of them, I'll actually show this example where I'm also animating so there is actually a link to a Vimeo movie. So let me try to open it and play it back from Vimeo. So this one was created using ParaView as well. And so here, what I'm doing is, so I'll explain in a second. Looks very complex, but it's actually really trivial to do in ParaView. So here I have a bunch of streamlines through a data set. And let me actually check. I can't remember if I included the data set into the, we're not going to do it now, but I just explained what's going on. So let's see, it's called disk. No, it's not there. Well, anyway, it doesn't matter. You can do this to any three-dimensional data set. So the idea is I drew streamlines, and then I actually have a slide for this. I drew streamlines, and then I apply a contour filter to the output of stream tracer line. So when I have a bunch of streamlines, basically a bunch of lines going through the volume, and apply a contour filter, what contour will do, it will basically chop these lines at a given position. And then at a given position, so after chopping, after this contour filter, I get a bunch of points to which I apply a glyph filter. So those moving spheres are glyphs. And then the only thing I do is I modify, basically I animate the position of the contour filter. So where the position at which I'm drawing the contour filter, and that repositions those small spheres, the glyphs, right? And then I just play it back in time, simply modifying the position of the the value at which I draw contours on streamlines, right? And so you can play with this. You can just recreate this, maybe using a different data set. So any three-dimensional data set will do. But the point here is you can create fairly complex visualizations using modifying a property of any pipeline object. So in this case, I'm modifying the position at which I draw the contours. So you can combine multiple timelines into a single movie. So let me show you an example. So here, what I can also do, let's say, fly around the object. So let's do 30 frames. If I play it back, it will be, just a familiar picture, right? But I can also spin it around. So what I can do, I can add another timeline. And instead of animating the clip, I'm going to be animating the camera position. And I'm going to make it orbit the data set. So basically, my data set is going to be spinning around the vertical axis. So I'm going to click Camera Orbit Plus. So new timeline, center, I think I'll just accept the default values. And now when I play it back, you will see that not only the slicing plane is moving, but I'm also spinning the object. So in fact, if I do more frames, you can see it more clearly. So now the slice is moving and the object is also spinning in 3D. And you can have more complex trajectories for the camera. So for the camera, you can also have, so here, instead of doing the orbit, you can do follow path or follow data. So follow path lets you define a path by hand or numerically. You can have a spreadsheet of points through all, you basically draw a path line for the camera through all these points. And then you specify the focal point, the point at which the camera will be looking. But essentially, there is no limit to how complex your visualization can be. So every year, we run a competition for scientific visualization. So last year, we're actually chairing the worldwide IEEE scientific visualization contest. And here's a link to the contest. But why I'm showing this is because back in this webpage has a link to 2017 contest, where one of the visualizations was from a UBC grad student, and she created, not sure it's playing back audio as well, But what I want to show you is this visualization where she's combining not sure if you're hearing audio as well. She's combining multiple effects in a single timeline, so switching between different variables, flying around on some complicated path. And let's see, yes. And so then those moving points that I showed you before. So you have basically it's simulation of airflow around turbine blades. And as you can see, you see turbulence there, and the whole thing is rotating. She's switching between variables, adjusting the volumetric view, and lots of things happening. And but it's fairly straightforward to do. So this is a snapshot of your timeline, right? So this is how you do it in ParaView. So you can actually modify, if you click on any timeline, double click and modify the time. Let's say I want to do my clip only the last 80%, last 20% of the time, right? So time goes from 0.8 to 1. And so if I play it back, now it's only spinning. My clip is not moving, but now the clip is moving. Now I actually start, clipping the plane. Right? So you have full control over animation. And I have a link actually here to more complex animations. So this one is an animation. So a couple of years ago, I gave a webinar on photorealistic rendering with ParaView. So all of this is done with ParaView. And this one I created also from scratch in ParaView. Not simple, but fairly straightforward to do. So if you're interested, you can find this webinar on YouTube. Right, so the point here, you can actually do very complex animations, or like this one. So here I have an animation, photorealistic rendering with a refraction inside these glass tubes. So on all of this, ParaView can do fairly easily. Okay, so any questions about animation or anything we've covered so far? Any other questions? If not, then let's talk about 3D visualizations on the web. So in this last chapter, I wanted to give you to show you some ideas, some ways of putting 3D models or 3D visualizations, of the type we've done before in ParaView online. And why you want to do this? Well, maybe you just want to create a web page where you have 3D models and people can go there and play with the models themselves. So it's not just a static snapshot or a movie they simply play back, but they can actually interact with models, turn on and off different variables. They can spin it, they can zoom in, they can maybe click on some annotations and see additional details, etc. And it turns out there are many different ways of doing this. So one of the best pages for that doesn't show how to do this, but just demonstrating this capability is the website of the Smithsonian Museum. So they have this 3D digital gallery where they have a bunch of objects, so a bunch of artifacts from their collection, and you can click on an individual artifact. I don't know, let's click on this one, and you can actually interact with it in 3D. So the problem here is they're using their own tools, right? So it's all custom, proprietary JavaScript, and you can't really borrow their models easily because, oops, I know it's just static image. But yeah, this is 3D model. So this one I can actually spin, but you can do something like this in several different ways yourself as well, and I'm going to show you how. So recall the visualization toolkit library, the library for visualization that is the base of ParaView. So it was written in C++, later extended to Python, Java, and most recently to JavaScript. And so you can actually, so there is so VTK.js is a JavaScript library for scientific visualization on the web. And so everything we've done today, you can actually do in JavaScript as well. It's more complex than doing this in Python, but processing text, I don't know, but in terms of visualization, you can do all those things. But unfortunately, there's quite a steep learning curve. So I just want to mention that there is this possibility. So you can do similar visualizations on the web. And I'm going to show you an example, but I won't go through it because it's quite complex, and we certainly don't have time to study details. So also maybe last year, a couple of years ago, I gave a webinar on this on VTK.js. So if you're curious, the very last page in the slides contains the links to visualization resources. So you can find the recording there. But here's a simple example, which I think is included into your download. So let me check. So it's an HTML file glitz.html. Yeah, it's right there. So if you try to open it inside your web browser, you will see this, right? So basically a static visualization with a cone, and then at each point, I also place a glyph. And the entire code is in JavaScript, is right here. So this is the entire HTML page with JavaScript embedded. And as you can see, there's quite a lot of stuff going on. So you need to create these, various objects. You need to connect them and renderers, actors, and so on. So there's quite a lot of stuff going on. And this is certainly not the way you want to do this. So this is done using the VTK.js library, right? So VTK implementation of the VTK graphics library for the web. So fortunately, there are easier solutions. And one of the best ways of putting a visualization is actually based on this VTK.js library. So the people who wrote VTK and ParaView is the same folks. They also created this web application called ParaView Glance. So it's linked right here. You can read about this. There's a manual somewhere, documentation gallery. But the nice thing about it, so what it is once again, it's written in VTK.js essentially, and it's a web page where you can drop your own predefined objects. So in ParaView, you can extract any scene, any object as a scene, as a VTK.js scene, VTK.js file format, and then you can drop it on this web page. So that web page, you can, so there is a, let's see, so this one, the actual app, ParaView Glance app. So you will drop a file here, and I'll show you in a second the result. So this is running on their own server, right? But in principle, you can run this on your own server as well. So I don't know, maybe if you have some local computer help and you have a departmental web page, maybe you can talk to the folks who create this or who maintain this web page, and this can certainly be added fairly easily to an existing web page, right? So you can actually run your own server, and then that server can visualize visualizations that can be embedded on any public web page. But anyway, so let's just try an example. Let's go to ParaView, and let's draw something. So let me delete this clip, and let's draw a contour. I'm going to delete the animation view, and I'm going to apply to the original data set. I'm going to apply a contour filter at the value of density equal to 0.15. So this will create this strange looking, structure, right? And what I'm going to do next is I'm going to export it as a VTK.js file. Actually, even when I go there, let me do something slightly more complex. Let me apply a clip to this guy. So I'm going to apply a clip to this guy, and I want it to be a horizontal clip, so normal to the y-axis. Apply, let me do something like this, so slightly more complex. So now I even have two objects, right? I have the original clip, and I have these skeleton structure. So I'm gonna go here and I'm gonna save it as a scene, not as a data, not as animation, but as scene. And I'm gonna choose the VTK.js file format, VTK.js file, and I'm gonna just call it a cube. So cube.vtk.js into the same, I guess, downloads folder. Okay. So here it created a file, cube.vtk.js, and what I can do next is I can open the web page, and then I can take this cube.vtk.js file, and I will simply drag it here. So ask to confirm, I'll say load, and here we go. So now I'm looking at the same visualization right inside the web page, right? And actually have quite a lot of control. It's not as powerful in terms of control as the ParaView itself, but I can still do things, turn on and off different views. So here I have two objects. I have the contour and I have the clip, right? So I can actually, let's say, turn off the contour or turn off the clip. Where's my clip? Right here. Turn off the clip, right? I can change, opacity like this, or I can change the color scheme. Let's see. The point here is I have quite a lot of control, and this is it's essentially a web page, right? Visualization inside the web page. So right now, only I have access to this file, right? But the nice thing about VTK Glance is actually very easy to pass variables to the web page, specifying the location of your data file. So here I created a short link, right? So this short link on the website is a bit.ly link. It's actually pointing to, it's a short link to this more complex link. But what's going on here is, so here I'm loading the website. Let me just show the relevant. Yeah, so this is the website for ParaView Glance, right? And then it's passing a couple of variables. So it's passing a name of the file that I'm going to be dropping onto this this website, and then it's passing the URL, so where the file is, right? So this is the public URL. Basically, it's staying somewhere on GitHub, right? So the file that I showed is similar to the file I showed you before. It's on GitHub, but basically you're passing, name of the file and location of the file to this website, and that's it. So, and then if you either click on this link or on a shorter version of this link, what it will do is it will, and you can do this on your end, it will just open this. So it will open the private glance and will drop the data set onto this web page, right? And now you can do it. You can play with this on your own end. So this is by far the easiest way to plot to put polygonal, basically, two-dimensional surfaces, polygonal models onto the web. And it doesn't have to be a mathematical function. It could be, a scan, for example. You take a lot of images of an object from different angles, use photogrammetry to create a 3D model. This is going to be a 3D polygon, a polygonal mesh in 3D. And then you export it, let's say in Preview, you can export it as a scene, and then just drop it on the website, and then you will have something similar to this. And so this is a public link, the one you see in the slides. So that means that anybody can click on this link, so anybody in the world, and they can view this model and interact with this model, right? Which is fantastic.
Can this be embedded as an iframe or anything, or? Yeah,
so exactly, that's my next slide. So you can embed it as an iframe as well. So here's a very simple example, but essentially the same thing. So here I have JavaScript. The only reason I have JavaScript is to pass very long links, right? So instead of having just a giant link, I have several variables. So name and URL. But yeah, so there's a file embed.html, and if you open this file, you will see this embedded into an iframe. So embed. Oops. Did I not copy it? Oh, I apologize. I think I did not copy it, so I need to. Yeah, I will edit after the lecture. I will edit to the file. So, but let me. Yeah, actually, you can copy. I mean, you can just copy the text and I save it into an HTML file. But I just want to show you what it looks like. So I'm going to go to the source. So let's see, embed. Yeah, it's right here. So if I open this inside a web browser, this is what also just loading. So here we go. It's inside an iframe, right? And then you can have the rest of your page.
Where's this image living?
So this image is living. Let me show you the slide. It's living on GitHub. This is essentially the same example as previous slide, but just formatted as an iframe. But here's the location. So it's right here at this location on GitHub. So that's why when you click on this link, you can actually see it on your computer.
Yeah,
because
it's living on your GitHub.
Huh?
It's living on your GitHub, on your account.
Yes, but it's public database, so you can read it.
Yeah,
you have read access. Yeah, exactly. The point here, it could be any public location, as long as this link can be read by anybody. You can drop it as a link in this way, embed it or drop it as a link on for Preview Glance. So I find that Preview Glance is really fantastic. And so one shortcoming is cannot yet do animation. So you can only do static images, but they're fully interactive static images, right? In the sense that anybody can, play with the data, spin, zoom, turn on and off different fields and so on. So another way of putting your visualizations onto the web is this package called 3D, well, actually 3D Hop. Before I go to 3D Hop, let me just quickly talk about this. So there are various commercial 3D model hubs online. So I guess Sketchfab is probably one of the most famous ones, where there's a free tier. You can have a free account, and then you can upload your models there. And then they have a paid account as well. So I find it's quite useful in the sense that you can find quite a lot of interesting models there, and maybe you can even host things there as well for free. But of course, they have limits for how much stuff you can put there. So there's also a USDZ sharing platform. So USDZ is this new file format, relatively new, few years old from Disney, and it's quite good for three-dimensional objects. And if you go there, I think you can upload your models as well, and so these are just three-dimensional objects. Okay, so it doesn't show them on the web. It just downloads the objects, but then you can actually view them locally. Anyway, so what I'm going to want to talk next is 3D Hop. So 3D Hop is a package for putting 3D, well, humanities, social sciences related data, artifacts online in a very similar way to what we've seen before. Actually, it's very similar to the Smithsonian collection. And I can also do some additional stuff. So you can define, for example, hotspots on top of these 3D models. And then when you click on a hotspot, something will happen, like you open a new page, or will give you some more description of that hotspot, etc. And so it's an open source package. Actually, it's not really a package. It's just like a framework. It's an example, right? You can modify this example, and then you can create custom visualizations. So unfortunately, last time it was updated was in June 2020. It still works great. But I'm not sure whether they just think that the project is complete, or they don't have any plans to maintain it, or update it for new browsers, etc. I have no idea. But right now it works, and it's fairly interesting. So if you go to the website, there are a lot of there are really good documentation, lots of examples. So if I click on one of these guys, we'll actually show you an example of what it looks like, the result looks like. So you see that I have a 3-dimensional model, right? And there is not much, so there's not much in terms of interactivity here, but in principle, when you create your own, you can add more buttons, and you can add buttons for hotspots. So I'm going to show you a demo of doing this on my own computer. And then they have real nice documentation. So for example, how to do this? Well, they have complete description here. So you'll just need to read this. So I have a couple of demos I want to show you. You cannot really do this easily on your own computer because there's quite a lot of editing of files. So it's really framework. So essentially, you download their directories, and then you modify some files, and then you can serve them on these directories or files on a regular HTTP web server. So let me show you an example. What I've done here is I took a visualization from ParaView, so that skeleton we saw before from the sign envelope function, and I exported it as a PLY, so polygonal mesh model. So a very popular format. The only problem with taking that PLY is that, well, actually, if you export it as PLY, so in ParaView, go to File, Save Data, export it as PLY, you can use it in 3D Hub, but the result is not very nice. For some reason, ParaView doesn't save colors in the way that 3D Hub expects them. So the result will not be as nice in terms of colors. But what I can do, what I did a couple of days ago, is you can go to File, Save, Export Scene, and then export scene as a X3D, so it's a royalty-free 3D computer graphics format. And then in another piece of software called MeshLab, it's an open source package, MeshLab, for, I think it's multi-platform, basically for processing polygonal meshes. So there you can take this scene and then save it as a PLY file, and make sure in the save dialog that you save colors and vertex normals. And then you get a PLY file that you can actually put onto your website. So let me show you a demo. Don't do this because there's quite a lot of steps, but I'm going to go slowly. And then I'm also going to mail a recording. So this lecture is being recorded, so you can actually recreate things on your own. Just watch what I'm doing. So I'll just follow the steps that I described here. I'll drag it to a different screen, and then I will open my terminal. So here I'm going to go into a new directory, into a temporary directory, and then I'm going to copy a command to clone 3D Hub onto my local. So from GitHub into a local directory, I'm just going to call it 3D Hub -source. Right. So just cloning 3D Hub from GitHub. Then I'm going to go to directory inside 3D Hub source called minimal. And then there I'm going to create a directory models, and under the directory I'm going to call single res for single resolution, so single res. Okay. And then I'm going to copy the file sign envelope.ply. So I think that file was included into the zip download for today's workshop. So I have it in, I believe, in here. So it's called sign envelope.ply. And I'm going to copy it into the newly created directory. Then I'm going to copy their template HTML page into a page called index.html. And then I'm going to modify this page so their template is pointing to their own demo. So I want to show my demo. So basically, a cd command is a command for Bash that lets you modify something inside a text file. So inside index.html, I'm changing this line to this line. So basically pointing to my model, right? So I'm going to change it right inside. Oops, something is not right. I forgot this quotation. All right, so I made the change. And again, everything I'm doing, I'm just copying and pasting from the slides, so you can look at it later. And then that's it. And then I'm simply going to start a local web server, so you can do it in Python. http .server on port 80. So let's see if this works. Oh, my password. Oops. Okay, great. So, and then I'm going to open a page. So now I'm serving on port 80. I'm going to open a page on localhost, and port 80 is the default port for web service. So here we go. So here's the page that is being served by Python. And in fact, if I pause this, right, if I kill this and I try to reload it, you see there's unable to connect because it's actually a live web page working local on my machine. So here it is. So here's a basic instance of 3D Hop where I can zoom in, I can spin around, and there's a bunch of controls. So the reason why those controls were called, so when I was copying the file, it was 3D Hop all tools, right? So basically all tools that can be shown, just copy them into this demo. Some of them are useful, some of them are not. So you can change, you can, for example, clip things if you want. You can change, the perspective. You can measure things, let's say distance from here to here. It's 37 millimeters. So from here, let's say to here, it's 4 millimeters and so on. So whatever the units are, right? You can turn on lighting, but I find it's not particularly useful because, well, it doesn't really change the picture much. But anyway, so here you can put a basic visualization that I created in ParaView. But the nice thing, you can actually add more stuff to it. So you can add some additional controls, so-called hotspots. So the way this works is, let me actually do this demo. So I'm just be copying the commands from slide 80. I'm gonna go here, post this guy. And then I will go, so now I'm in the minimal directory. And then I'm going to copy a couple of files from the zip download for today. So the files are ring.ply, goes into same directory. And then another one is top.ply. Top.ply. So these are a couple of polygonal meshes that I will use as hotspots. So they are basically, I took the original mesh, the original sign envelope mesh. So this guy, and then using slicing in ParaView, clipping in ParaView, I created a couple of elements that I saved as additional polygonal meshes. So you will see them very shortly. And then I need to copy my example. So it's a custom example, which is also in my download. So it's under the zip download, you'll find the directory 3D Hop, and there I have the file hotspots. And I will simply copy to the current directory. And then I'm going to, again, serve it from Python. So starting a web server from Python. But now I will have to open this file hotspots.html. All right, so if I reload it, nothing happens. I need to point to the file. Actually, here's the address. So localhost hotspots, open this web page. And what's different here, there is a new button now, that this button, that lets you turn on hotspots. So now they're on, now they're off. And the hotspots, so there are a couple of polygonal meshes. One is the top, this guy. So when I mouse over it and I click on it, it will open the HSI homepage. Huh. And then this guy, so the ring, when I click on it, it opens, it's a JavaScript element, so it opens this small alert with some information, right? So this way you can actually add some description to your visualization. But just a very simple example. So there are many more. Well, there are some additional examples on the 3D Hop website But I find it's a very, very useful tool, especially for people with no programming experience. Basically, you need to take their template, modify it, and then serve it on a web server, and it should work. So yeah. Anyway, so that's all I have for today. So I think I went a little bit faster than expected for the afternoon session. If there are any questions, feel free to unmute yourself, ask now. You can always send me an email. Well, not personal, my work email is alexir@sfu.ca. You can also send, if you send an email to support@computecanada.ca. So this is email for Canadian researchers who use our facilities. But basically, if you send an email to this ticket, to this address, it will open a support ticket in Compute Canada. Well, now it's called the Alliance. So we changed the name a couple of months ago. The Alliance, and basically, if you have any, if you use either if you are at a Canadian university, or you are, let's say you are in the US, but you have a collaborator at Canadian University and you work on the same project, you can still ask us for help. We'll be happy to answer you. But otherwise, just send me an email to my SFU address. Also, a couple of links. So the first one is, I think I already briefly showed this to you. So CCVs is so in Compute Canada, in the Alliance, we have a national visualization team. We have about 10 folks or so who are interested. I mean, they are analysts and trainers, etc. But they're somewhat interested in scientific visualization. So here's just a page that shows some, typical visualizations that we can create. And there are some nice images. So this image was created by a researcher, for example. This visualization was also created for a researcher, but yeah, this is done in ParaView, so you can easily recognize the ParaView color map. So I know this is done in ParaView, right? So things like this are fairly trivial to create. But again, most likely you're not doing weather modeling or atmospheric simulation. You're doing something different. But if your data can fit onto any of the discretizations that I showed in the morning, then you can easily visualize it in ParaView.
Alex,
Right,
I have a question.
Yeah, go ahead.
It's like a conceptual question. Like, when does it stop being a data visualization and when does it just start being art?
Well, I can't really answer this. So I think I haven't done any art myself, so any artistic visualizations, but basically what I'm doing is I have data sets. I'm trying to visualize them, right, to answer scientific questions. So try to understand what's going on in the models. And I load those data sets, let's say in ParaView, and I try to understand what's going on, right? So there's no artistic component to it. But I guess, it comes to art when you try to do something unusual, right? So for example, I can show you actually a nice example from, let's see if I'll go to SciVis, the 2021 Scientific Visualization Contest, and go to results. So one of the, so the top first place winner, they created scientific visualizations that kind of artistic, right? Because what they've done, they have these nice color maps. There's actually nothing special. They're very special, but there's nothing unusual about these color maps in the sense that they just chose color maps in such a way that they have, these nice, semi-artistic, these nice pictures, right? And the trick here, why do you see those black bands, is because if you zoom in, if I can zoom, if you zoom in on the color maps, the color maps have these bands. And that's just the way these bands show up in these visualizations, right? So this is kind of artistic, and they don't invent anything. They still show real data, right? But this visualization is kind of done very nicely. So it's very difficult to answer this question, because if you're modifying your data in some way, there's certainly art, right?
Yeah.
But if you're trying to come with some innovative ways to do things, so here's, for example, another way. I really love this visualization. So what they try to do is they try to visualize Earth mantle convection. And the problem is it's very difficult because it's a sphere, right? So you're looking inside the sphere. And what they did, they actually unwrapped the sphere onto a plane. So it's actually a spherical data set, then wrapped it onto a plane. And then now they have notions of up and down. So this is up, this is down, and then you have hot plumes rising up, cold slabs going down. And if you play this, so I don't have a movie here, but if you play this movie, it's really shown nice, like you have things going up and then cold material raining down. And this is kind of art, in my opinion, because even though it's it's real scientific visualization, real data, it's done in such an unusual way that it's almost art.
Thank you so much. This is amazing.
Yeah, no problem. So, and the second link, the very last link in the slides is the link to our visualization resources. So the only reason I'm showing is we've done over the years quite a few, about 20 or 25 different webinars on scientific visualization. So there's, for example, photorealistic rendering. Oops, if I search photorealistic rendering with ParaView, or web-based 3D visualization, lots and lots of things, and all these things. So you have the slides, and for all of them, you have the slides and the recording as well. So if you're interested in any of these topics, maybe you'll find something useful for your research. All right, so I think, there's a question in the chat. Yeah, I haven't been paying attention to the chat. Is Jupyter the only web app that works with this, or Google Colab? No, you can use, you can use, so the examples that were showed today, you can use Google Colab for pretty much everything we've done today, except, so the only thing is, I don't know what packages Google Colab has installed. So I assume you can probably install your own packages, but things like VTK and NetworkX, they're not obscure, but they're not the packages people usually use with Python, especially VTK. So I'm not sure if you will need to install it, ask them to install it, or they already, Google Colab, I mean, or they already have it installed. But essentially, it comes up to packages whether those been installed or they have to be installed for your project. So, but yeah, otherwise, all examples I showed you today, you can already install, right? So yeah, you should be able to run them in Google Colab as well.